Los Angeles, a sprawling metropolis nestled between the Santa Monica Mountains and the vast Pacific Ocean, is no stranger to wildfires. These fiery infernos, fueled by dry chaparral and driven by relentless Santa Ana winds, have become an unfortunate hallmark of the region. With the ocean so close, it's tempting to imagine using its seemingly endless supply of water to combat these blazes. After all, what could be more readily available than the vast Pacific? The reality, however, is far more complex. While the idea of using ocean water to douse wildfires might appear simple and effective, it's fraught with challenges, making it an impractical and even detrimental solution. From the corrosive nature of salt water to the potential environmental damage and logistical nightmares it presents, harnessing the ocean for firefighting is not as straightforward as it might seem. This essay delves into the multifaceted reasons why using ocean water to fight wildfires in Los Angeles is not a viable option, despite the ocean's proximity. We'll explore the scientific, logistical, and environmental factors that make this seemingly appealing solution more problematic than practical. By understanding these limitations, we can better appreciate the complexities of wildfire management and the need for innovative yet sustainable approaches to protect lives, property, and the environment. One of the primary reasons why using salt water for firefighting is impractical lies in its highly corrosive nature. Firefighting equipment, particularly pumps, hoses, and nozzles, is primarily made of metal. Salt water, with its high salt content, acts as an electrolyte, significantly accelerating the corrosion process in these metallic components. Imagine pouring salt water through a network of pipes and valves. Over time, the salt would crystallize, corroding the metal and weakening the entire system. The same principle applies to firefighting equipment. Continuous exposure to salt water would lead to rapid deterioration, rendering pumps ineffective, hoses prone to leaks, and nozzles clogged with salt deposits. This corrosion would not only compromise the efficiency and effectiveness of firefighting efforts, but also pose a significant safety hazard to firefighters who rely on their equipment's integrity during high-pressure situations. The potential for equipment failure during a wildfire, when lives are at stake, is a risk that cannot be taken lightly. Therefore, the corrosive nature of salt water makes it an unsuitable choice for combating wildfires. Beyond the damage to equipment, using salt water on wildfires poses a serious threat to the already fragile ecosystem of the Los Angeles region. The chaparral landscape, while adapted to periodic fires, is sensitive to changes in soil salinity. Introducing large volumes of salt water would drastically alter the soil composition, making it inhospitable for native plants. Many of these plants are specifically adapted to low-nutrient, low-salt conditions. The sudden influx of salt would act as a toxic shock, killing off vegetation and disrupting the delicate balance of the ecosystem. This ecological damage would extend beyond plant life. Animals that depend on these plants for food and shelter would also be impacted. The result would be a cascade effect, disrupting the entire food web and potentially leading to the decline or even extinction of certain species. Therefore, while seemingly a quick fix, using salt water on wildfires would leave behind a legacy of environmental damage far outlasting the flames themselves. While it seems intuitive that water, regardless of its source, would extinguish fire, the reality is more nuanced. When it comes to firefighting, not all water is created equal. Salt water, while abundant, is inherently less effective at extinguishing flames than fresh water. This difference in effectiveness stems from the chemical properties of salt water. The dissolved salts in ocean water lower its heat capacity compared to fresh water. Heat capacity refers to the amount of heat energy required to raise the temperature of a substance. In simpler terms, fresh water can absorb more heat before its temperature rises significantly. This property makes fresh water more effective at cooling down and ultimately extinguishing fires. Salt water, with its lower heat capacity, requires a larger volume to achieve the same cooling effect. This difference might seem negligible in a laboratory setting, but in the chaotic and high-stakes environment of a wildfire, it could make a significant difference in containing and suppressing the blaze. Section 5. Logistical nightmares, terrain, wind, and the unwieldy ocean. Even if we disregard the corrosive and environmental concerns, the sheer logistics of transporting vast quantities of ocean water to combat wildfires present insurmountable challenges. The rugged terrain of the Los Angeles basin, characterized by steep canyons and dense chaparral, makes it extremely difficult to lay pipelines or establish a reliable water transportation system from the coast to the fire lines. Furthermore, the infamous Santa Ana winds, often responsible for fanning the flames of these wildfires, are unpredictable and can shift direction rapidly. These erratic wind patterns would make it nearly impossible to accurately target water drops from aerial firefighting efforts, rendering them ineffective and potentially even dangerous. Imagine attempting to aim a fire hose at a target while standing on a moving platform, with the wind changing direction every few seconds. This scenario illustrates the difficulty of using ocean water for aerial firefighting in such unpredictable conditions. The logistical challenges posed by the terrain, coupled with the unpredictable nature of the Santa Ana winds, make the prospect of utilizing ocean water for firefighting in Los Angeles a logistical nightmare. Section 6. Sticking with tradition, the methods and challenges of land-based firefighting. Given the limitations of using ocean water, firefighters rely on more traditional methods to combat wildfires in Los Angeles. These methods involve a combination of ground-based firefighting crews, specialized vehicles equipped with water tanks and pumps, and aerial support from helicopters and airplanes. Firefighters on the ground work tirelessly to create fire breaks, clearing vegetation to starve the fire of fuel. They use high-pressure hoses connected to hydrants or water tankers to douse the flames directly. However, even these traditional methods face significant challenges. One of the most pressing issues is the availability and reliability of freshwater sources. As wildfires become larger and more frequent, they put a strain on local water supplies. Low water pressure and hydrants can hamper firefighting efforts, and the depletion of reservoirs can have cascading effects on the community, impacting drinking water availability and agricultural needs. Section 7. Resource depletion, a growing concern in the face of raging fires. The increasing frequency and intensity of wildfires fueled by climate change and human activity are exacerbating the problem of resource depletion. As wildfires consume vast swaths of land, they not only deplete water resources, but also destroy critical infrastructure, including power lines, communication towers, and transportation routes. This destruction further hinders firefighting efforts and hampers the ability of communities to recover from these disasters. The economic costs are staggering, with billions of dollars spent annually on fire suppression, infrastructure repair, and lost economic activity. The problem of resource depletion highlights the need for a more sustainable and holistic approach to wildfire management. This approach must encompass not only effective firefighting techniques, but also preventative measures such as reducing fuel loads through controlled burns and implementing stricter building codes in fire-prone areas. Section 8. Conclusion. The need for sustainable and effective firefighting strategies. The allure of using the seemingly endless Pacific Ocean to combat wildfires in Los Angeles is understandable. However, as we have explored, this seemingly simple solution is fraught with practical, environmental, and logistical obstacles. The corrosive nature of saltwater, its detrimental impact on the delicate ecosystem, its lower effectiveness compared to freshwater, and the insurmountable logistical challenges of transporting and deploying it make it an unviable option. Instead, firefighters must rely on traditional land-based methods, which themselves face growing challenges due to resource depletion and the increasing frequency and intensity of wildfires. Moving forward, it is crucial to invest in research and development of innovative firefighting technologies and strategies that are both effective and environmentally sound. This includes exploring the use of fire retardants with minimal environmental impact, developing more efficient water delivery systems, and implementing proactive measures to reduce the risk of wildfires in the first place. By adopting a comprehensive and sustainable approach, we can better protect lives, property, and the environment from the devastating impacts of wildfires in the future.